Iosif Stalin 7 is the heaviest Soviet tank in history, which could destroy everything. In the Kubinka Tank Museum stands a machine for which people come from all over the world. 68 tons of steel, 12 machine guns, a naval cannon with a caliber of 130 millimeters, and armor 350 millimeters thick. This is the Iosif Stalin 7, the heaviest and most powerful tank ever created in the Soviet Union. A machine that could pierce any German tank right through from a distance of 2 kilometers, but which never actually made it onto the battlefield. The story of how Soviet engineers created a true monster that was decades ahead of its time, and why the military command grew afraid of their own creation. In the spring of 1945, Soviet tank columns were moving irresistibly toward Berlin. T-34s and heavy Iosif Stalin IIs were grinding down the remnants of the German defense. But the command was already looking into the future. On the battlefields, German Jagdtigers and King Tigers had appeared with armor that even the powerful guns of Soviet heavy tanks could not always pierce. It became obvious that a fundamentally new machine was needed, one capable of dominating any battlefield of the next Great War, should it happen. In June of that same year, a group of designers gathered at the Kirov plant in Leningrad under the leadership of Nikolai Shashmurin. This man had already managed to become famous for his work on the heavy tanks of the Kliment Voroshilov and Iosif Stalin series. But now he faced a task of a completely different scale. It was required to create a machine that would withstand a hit from any existing tank gun and at the same time could itself destroy any enemy armored vehicle at maximum distances. The project received the factory designation Object 260. Shashmurin understood that the problem could not be solved by a simple increase in armor thickness. The tank would become unmanageably heavy and clumsy, just as had happened with the German Maus, which could barely move under its own weight. Soviet designers took a different path and placed their bet on rational angles of inclination of the armor plates. The front part of the hull received a characteristic shape, which tankers later nicknamed the pike nose. The upper frontal plate was located at an angle of 65 degrees to the vertical, which made the effective thickness of the armor simply monstrous. A shell hitting such an obstacle did not pierce it, but slid off, losing most of its energy. The designers carried out calculations and concluded that the frontal projection of the new tank would withstand a direct hit from a 128mm shell of a German Jagdtiger from a distance of more than a kilometer. This was an incredible achievement, because the gun of the Jagdtiger was considered the most powerful anti-tank weapon of the Second World War. Not a single serial tank of that time could boast a similar level of protection, but Shashmurin did not stop at the frontal armor. The sides of the hull also received 150 millimeters of steel located at an angle. Such a solution was absolutely unprecedented for that time. Even the German Tiger II had side armor of only 80 millimeters, and the Soviet Iosif Stalin III had even less. The new tank was to become practically invulnerable to attacks from any direction. The turret represented a separate masterpiece of armoring. Its frontal part had a thickness of 240 millimeters, and the gun mantlet reached 350 millimeters of cast steel. With such parameters, not a single existing anti-tank weapon could guaranteed hit the machine in the frontal projection. Soviet engineers had actually created a mobile bunker capable of withstanding the fire of an entire battery of anti-tank guns. However, such powerful armoring inevitably led to an increase in mass. First calculations showed that the tank would weigh more than 60 tons, which created serious problems with mobility and transportation. Most bridges in Europe simply would not support such a machine, and railroad platforms would require a serious modernization. But the designers decided that firepower and security were more important than logistical difficulties. The war had taught them that it is better to have a few invulnerable machines than hundreds of vulnerable ones. By the autumn of '45, the project took concrete shape. On the drafting boards of the Kirov plant appeared the contours of a machine that was destined to become the pinnacle of Soviet heavy tank construction. Years of testing, refinements, and a struggle for every kilogram of weight lay ahead. But even then, it was clear that something special was being born. When the basic concept of armoring was approved, the designers faced a no less difficult task. A machine weighing almost 70 tons had to do more than just crawl across the battlefield. It had to maneuver swiftly, overcome obstacles, and develop a speed comparable to much lighter medium tanks. For this, a fundamentally new chassis was required, and the engineers of the Kirov plant made a real technological breakthrough. For the first time in the history of Soviet tank construction, tracks with rubber metallic joints were installed on a machine. Before this, all domestic tanks used all-metal tracks, which made a deafening clatter when moving and wore out quickly. The new design allowed for a significant reduction in noise and an increase in the service life of the track belt. Each track link was connected to the next by a single pin fixed with bolts, which simplified field repair and the replacement of damaged links. On each side of the hull, 7 large-diameter road wheels were placed. The wheels themselves received steel-cord tires with internal cushioning, similar to those used on some German tanks of the feline family. Such a solution reduced vibration and increased the service life of the outer surface of the road wheels, although it preserved the characteristic noise of metal on metal during movement. Each road wheel was installed on an individual swing arm connected to a torsion bar, while additional hydraulic shock absorbers ensured a smooth ride even over rough terrain. Special attention was turned to the bump stops in the form of coil springs, which limited the movement of the swing arms and prevented the road wheels from hitting the hull when overcoming serious obstacles. Track tension was adjusted using a hexagonal screw, the rotation of which in one direction or the other allowed for the prompt tightening of a sagging belt right in field conditions. The system was simple and reliable, which was especially valued by the military. But if the chassis aroused admiration for its thoughtfulness, the decision of the designers regarding the auxiliary armament still causes debate among historians. An incredible number of machine guns were installed on the Joseph Stalin 7, as if the engineers had decided to turn the tank into a mobile fortress capable of firing in all directions simultaneously. On each side of the hull in the front part, one stationary bow machine gun RP-46 of 7.62 mm caliber was mounted. This weapon was controlled by the driver. Moreover, to aim, he had to turn the entire tank to the left or right. Vertical guidance was carried out using the gas and brake pedals, which turned shooting into a real circus act. One can only imagine what pleasure the crew inside experienced, while the driver had his fun trying to hit a target somewhere in the distance with a burst. The machine guns were protected by armored shrouds, and the ammunition was stored in special compartments and fed to the weapons through chutes. Empty ammunition belts exited through an opening at the top, and spent cartridge cases flew out through the lower slots. The system worked autonomously and did not require the participation of other crew members. It seemed to the designers that 4 bow machine guns were not enough, so 2 more RP-46 guns pointed backward appeared on the rear of the hull. This allowed for firing at enemy infantry trying to approach the tank from the rear without turning the turret. On the turret itself, a pair of rear machine guns RP-46 of the same caliber were also installed, shifted to the sides to leave room for ammunition boxes. Spent cartridge cases were neatly dropped into small metal containers. It was practically impossible to conduct aimed fire from the turret machine guns. The only relatively workable method was for the commander to turn his cupola, look back, determine the direction of shooting by the tracers, and shout to the gunner to turn the turret. The effectiveness of such a system was extremely doubtful, but the ammunition suppliers certainly remained pleased. Crowning all this magnificence was a heavy anti-aircraft machine gun KPVT of 14.5 mm caliber on a high mount. The mount turned out to be so bulky that the commander physically could not fire while remaining inside the turret. He had to climb outside and stand on the rear completely open to enemy fire. This contradicted all the principles of security that were so carefully observed during the design of the armor. In total, about 2,500 rounds of 7.62 millimeter caliber and around 400 rounds for the heavy machine guns were placed on the tank. Carrying such an arsenal was burdensome, and the practical usefulness of most of the machine guns remained questionable. Subsequently, the testers admitted that at least 5 of them could have been removed without pain, and the machine would only have benefited from this. On the sides of the hull, there were fold-down panels under which various equipment was stored. In the same place were inflatable fuel tanks made of rubberized fabric, resembling canvas bags. The idea was borrowed from earlier machines where external fuel containers were attached directly to the sides, but the soft tanks turned out to be more compact and convenient to store. These panels had to be opened manually, and if heavy tools like jacks were fastened inside, only 2 or 3 people could return the cover to its place. Creating powerful armor and a reliable chassis was only half the battle. Now the designers had to solve the main problem of all super-heavy tanks, to find an engine capable of moving this steel giant from its spot and at the same time ensuring its decent mobility on the battlefield. The German Maus, weighing 188 tons, barely crawled at a speed of 20 kilometers per hour, and its power plant constantly overheated. Soviet engineers were not going to repeat the mistakes of others. The choice fell on the M50T engine, which was originally developed for torpedo boats. This was a 12-cylinder water-cooled diesel that delivered a fantastic 1,050 horsepower for that time. Not a single serial tank motor of that period could compare with it in power. For comparison, the engine of the T-34 developed about 500 horsepower, and the power plant of the heavy Iosif Stalin II delivered only 520. The naval origin of the engine created certain difficulties with the layout. The motor occupied a huge space in the rear part of the hull and required a powerful cooling system. The designers placed the radiators and fans in such a way as to ensure maximum airflow through the engine compartment. On the upper part of the rear, armored plugs of the filler necks for pouring cooling liquid, engine oil, and transmission oil appeared. Access to the power plant for maintenance and repair became a serious problem. Unlike most tanks of that time, the Iosif Stalin 7 did not have the usual hatches in the engine compartment. Neither large fold-open covers, nor even small round hatches like on the T-34 or the Iosif Stalin 3. To get to the engine, mechanics had to unscrew huge bolts around the perimeter of the rear panel, and then use a crane to lift the entire upper part of the rear as a single whole. The procedure was incredibly labor-intensive and required the presence of special equipment, which made field repair practically impossible. The developers understood this limitation and planned to refine the design if the machine went into serial production. Well, for the prototype, they decided to leave everything as it was, focusing on testing the main systems. On the other hand, the results of the running tests exceeded all expectations. Despite a combat mass of more than 68 tons, the tank accelerated to 60 kilometers per hour on the highway. This was an incredible speed for a machine of this class, comparable to the performance of much lighter medium tanks. The transmission also deserved separate attention. On early models, a 6-speed gearbox was installed, but subsequently it was replaced by an 8-speed one, which ensured smoother acceleration and better adaptability to various terrain conditions. The shift lever worked intuitively. You start with first gear and gradually shift higher. A separate lever was responsible for choosing the direction of movement. Moreover, its logic was somewhat unusual. The forward position engaged reverse gear, and the rear position engaged forward gear. Now about the main caliber. The designers understood that for a breakthrough tank, a gun was needed that was capable of destroying any enemy fortifications and armored vehicles at maximum distances. The choice fell on the S-70 gun of 130 millimeter caliber, created on the basis of a naval gun. The barrel length was almost 7 meters, which provided the shell with a colossal initial velocity of 900 meters per second. An armor-piercing shell weighing 33 kilograms pierced the frontal armor of any existing tank at a distance of over 2 kilometers. For comparison, the famous German 88mm anti-aircraft gun, of which the Wehrmacht was so proud, had an initial shell velocity of about 800 meters per second and was significantly inferior in piercing power. High-explosive fragmentation ammunition turned out to be no less impressive and could smash field fortifications, bunkers, and light armored vehicles to splinters. The rate of fire of the gun was 5 rounds per minute when using the loading mechanism, and with manual loading it dropped to 1 round. However, this figure was true only for the first shells already located in the conveyor. After the ammunition load of the mechanism was emptied, the firing speed dropped sharply, because loading new ammunition required significant time. In addition to the main caliber, it was planned to install a twin heavy machine gun of 14.5mm caliber and 2 SGMT machine guns of 7.62mm caliber in the turret. On the museum specimen, the heavy machine gun looks as if it was first dismantled and then hastily returned to its place for the exhibition. The standard mount is missing, and the twin machine guns of smaller caliber are not installed at all, although the mounting seats for them have been preserved. The ammunition load of the main gun consisted of about 30 rounds of separate case loading. The shells and the casings with powder were stored separately in special racks throughout the fighting compartment. Such a scheme reduced the risk of detonation when the armor was pierced, but complicated the work of the loaders, who had to manipulate 2 heavy elements instead of 1 unitary cartridge. The internal arrangement of the turret of the Iosif Stalin 7 amazed with its thoughtfulness, and at the same time presented the crew with serious trials. The fighting compartment accommodated 4 people: the commander, the gunner, and 2 loaders, each of whom was assigned a strictly defined place in this steel labyrinth. The commander cupola was located in the right rear part of the turret and provided fairly comfortable working conditions. In front, nothing obstructed the view, and the distance to the back of the gunner left enough free space so that the knees of the commander did not press against his neighbor. 3 square vision prisms located around the perimeter of the cupola served for observing the battlefield. They were not elongated like on most tanks of that time, so the field of view through each of them turned out to be narrower than usual. However, the main tool of the commander was a rotating periscope placed in the hatch cover, which allowed for scanning the terrain all 360 degrees. Right behind the back of the commander was a rack of shells, which did not allow him to lean back and relax during a march. Next to the seat were ammunition boxes for cartridges of 14.5mm caliber, and a little further, a rack for cartridges of smaller caliber. In the same place was the control panel for the internal communication system, which allowed the commander to give orders to all crew members. An interesting feature of the design was the absence of a turret basket in the usual sense. Instead, there was a kind of platform on which the crew could place their feet. However, the protective guard that protects limbs from getting caught in the turret traverse mechanism is missing on the museum specimen. Perhaps it was dismantled for inspection, or maybe they plan to install it later when starting serial production. Tankers jokingly called the rotating mechanism of the turret a monster that, when turning, grabs various objects and hides them somewhere inside. Usually, necessary small items like a compass or radio station codes became victims, but sometimes the monster could also grab a careless tanker by protruding parts of the body. The loaders' positions were located on both sides of the breech of the gun and were practically identical. The seats themselves have been dismantled on the museum specimen, but the racks for storing ammunition, which occupied almost all the free space, have been preserved. From the inside, the slope of the side armor plates is perfectly visible, and the shell racks are located right above them. The crampedness was unimaginable, and the loaders had to work in conditions that resembled a submarine more than a tank. The main highlight of the fighting compartment was the loading mechanism with a conveyor. This was a semi-automatic system that significantly eased the work of the crew during firing. 7 shells in the upper part and 6 casings with charges in the lower part were placed simultaneously in the mechanism. After a shot, the breech block opened automatically. The spent casing fell out and hit a small metal chute below, which deflected it to the side. The loading process looked as follows. The loader moved the next shell, which fell onto the conveyor and began moving toward the breech. Then he repeated the same operation with the casing of the powder charge. When both elements approached the gun, the conveyor tray rose parallel to the roof of the hull, bringing the ammunition onto the loading line. However, the conveyor did not ram the shell all the way, and an electric rammer was used to complete the operation. If the loading mechanism failed, the crew had to switch to manual mode. For this, the loaders took a special T-shaped manual rammer and manually shoved the shell and the charge into the breech. The breech block rose and closed the powder chamber. After this, the gun was ready for a shot. The procedure was repeated until all 6 pieces of ammunition in the mechanism were consumed, plus the one that had been loaded initially. Then it was required to load shells onto the conveyor again. The work of the loaders was complicated by the location of the ammunition racks. Part of the shells was stored near the gunner's seat, and to get them, he had to lift himself up from his place. The designers provided a special recess in the back of his seat through which the loader could reach the necessary ammunition. But still, this was extremely inconvenient. Most likely in a real battle, the crew fired the ready shells from the mechanism, and replenishment was done already during a lull. The gunner's position was to the left of the gun and was distinguished by some crampedness. The manual guidance control instruments were located right in front of his chest and limited legroom. Even a person below average height would experience certain inconveniences. The main sight was placed in such a way that the gunner pressed his forehead against it when conducting fire. This same sight was used for firing the twin machine guns. The fire control system was familiar to modern tankers. Handles with triggers allowed for controlling the entire guidance complex. Vertical guidance was carried out by tilting the handles forward or backward, and horizontal guidance by turning the entire mechanism to the right or left. Such a principle differed from most Soviet and Western tanks of that time, where horizontal guidance resembled turning a car steering wheel more. To the left of the gunner was a manual drive for turning the turret in case the electric motor failed. 2 vision instruments, similar to those that the commander had, provided the gunner with a limited view. There is no periscope for all-around observation on the museum specimen, although the mounting seat for it has been preserved. Probably this instrument was planned to be installed on serial machines. The driver's compartment was located in the front part of the hull and was intended for the driver, the only crew member isolated from the rest in the fighting compartment. He could get to his position through an individual hatch in the frontal armor plate, which slid to the side along guides. The workspace itself made a favorable impression with its spaciousness and the thoughtfulness of the layout. The seat was adjustable in height, which allowed for adjusting it to the height of a specific tanker. True, the cushion turned out to be so thin that during long marches, the driver had a hard time. Experienced mechanics probably took their own cushions with them to somehow soften the shaking on rough terrain. But otherwise, the ergonomics did not cause complaints. 7 vision instruments served for observation, 3 periscopes in the roof of the hull on the sides of the hatch, 1 central one in the cover itself, and 3 more prisms in the frontal part. Such an amount of optics provided the driver with an excellent view, which was critically important when maneuvering a multi-ton machine in combat conditions. If necessary, he could open the hatch slightly and drive the tank with his head sticking out. But in battle, such a luxury was unacceptable. To the left of the seat was a rack for machine gun ammunition of 7.62 mm caliber. Nearby was a shelf for storage batteries, which are missing on the museum specimen, but the wires for connecting them have been preserved. The instrument panel looked standard for Soviet equipment of that period, without any revolutionary solutions. The only unusual element was the speedometer placed on the right edge. Such a location had been encountered before only on tanks of the T-series. The engineers placed the power switch right between the driver's legs, which caused certain inconveniences. The starter button was in front of the knees. The horn deserved separate attention. On a combat machine, it seemed like an amusing excess, but it was necessary when moving in a column or through populated areas. To the right of the seat were cylinders with compressed air for the pneumatic engine starting system. In the conditions of a harsh Russian winter, when frosts dropped below -30 degrees, a regular electric starter might not cope with starting a cold motor. Then the mechanic opened the valve, compressed air entered the cylinders, and turned the crankshaft until the engine caught. The system was reliable and more than once saved tankers in the most difficult conditions. Control was carried out using 2 levers, which simultaneously performed the function of brakes. A brake pedal was absent as such, and for fixing the machine in place, locking buttons on the upper part of the levers served, turning them into a parking brake. The system was progressive for its time, although it did not allow for turning on the spot, as tanks with steering clutches could do. Nevertheless, controlling the Iosif Stalin 7 was significantly easier than machines of previous generations. In the same place were several fire extinguishers, a telescopic mechanism for opening the heavy hatch cover, and a hand throttle lever. In special compartments, spare lamps for instruments, individual first aid kits, and other small things necessary on a march were stored. Behind the seat were ammunition boxes for the bow machine guns. By 1948, 6 prototypes of the Iosif Stalin 7 had been built, which passed a full cycle of factory and state tests. The machines showed outstanding characteristics in all main parameters of mobility, protection, and firepower. It would seem that the path to serial production was open, but the military command made an unexpected decision. In parallel with the Iosif Stalin 7, another heavy tank was being developed, which received the designation Iosif Stalin 8 modification, and was subsequently adopted into service under the index T10. This machine was inferior to the Iosif Stalin 7 in practically all parameters. Its armor was thinner, its gun was weaker, and its speed was lower. However, it had one undeniable advantage: the price of production and simplicity of operation. The Iosif Stalin 7 required special equipment, rare materials, and highly qualified workers for manufacturing. Its 12-cylinder naval diesel cost as much as several regular tank motors. The loading mechanism was distinguished by complexity and capriciousness, and repair in field conditions was practically impossible due to the lack of access hatches to the engine. Transporting a machine weighing almost 70 tons created a logistical nightmare. Most railroad platforms and bridges simply would not withstand such a load. The Iosif Stalin Box 8 weighed 20 tons less, used proven components and assemblies, was easily repaired by the forces of the crew, and could be transported by standard transport. In the conditions of the post-war economy, when the country was recovering from terrible destruction, the cost factor turned out to be decisive. The generals rightly reasoned that it is better to have 3 reliable tanks than one magnificent but capricious one. In total, 6 machines of the first experimental series and a few units of a small pre-production batch were produced. After the closure of the program, most of the prototypes went to be melted down or were used as targets on firing ranges. By a miracle, only one specimen survived, which today can be seen in the Kubinka Tank Museum, where it stands next to its German antipode, the giant mouse.